Warning, this video is going to be long and nerdy. We had a subscriber ask us if we could go into more detail on our project. So we're going to show you how to use KiCAD to make your own printed circuit board. This is an ESP8266. We're going to use it in our next project, but we need a circuit board that can program. So Walnut's going to show you how to do it in the open source software KiCAD. Let's get to it.
So with KiCAD, you just download that. It's a free software for laying out printed circuit boards all the way to the point of rendering your circuit board in 3D. To start, you simply just create a new project and give it a name. Right now, I am bringing in a picture of the pinout for the ESP8266. I'm going to put that right here on the sketch that way, or on the schematic. That way I can use it as reference for the pinout. Kind of get it centered here. All right, so now I'm ready to add my first components. I'm going to add the various pin headers. And so we do that by clicking that icon there. And then you go looking for pin headers. So we'll scroll down through here. And where they have them is under the, by default, the CON connector library. And we'll take a look at it. So looking down through there, have different configurations of pin headers. Pin headers can come in all kinds of different center-to-center dimensions. What we're looking for is your standard 2.54 millimeter 2x4, just like the ESP8266 has. So we'll lay that one down, and let's relabel this connector. That way we'll know which one's which. And I'm doing this just by right-clicking and then selecting Edit Value. Okay, now we're ready for the other connector. The other connector is going to be, basically what we're building here is a printed circuit board to program this ESP8266. That way it's real quick and easy to just stick it on this board we're making, and then use our PC to actually program the code to the ESP8266. So the other connector I need is to an FTDI cable, which is used to actually talk to the PC, or so the PC can talk to it. That way you can program it. Now we set it down. I hit the R key on the keyboard to rotate it, and now I'm going to right-click and edit the values again. Well, we know what it's for. I'm going to put dash over here. And tell you what, really what I need to do is get another graphic for the FTDI cable. So I'm going to get rid of that. I'm going to put FTDI there. Then I'm going to go get a graphic off the internet of the pinout for the FTDI cable. Let me first finish changing this up. There we go. Let's jump over to element 14, go to the store, and we'll do a search for FTDI. FTDI cable. Look down through there. There's one. We want the one that's USB to TTL. That way we can talk to it with TTL, transmit, receive pins. Yeah, that looks like it. A lot of these have the same pinout order. So now I'm going through the data sheet. I'm going to find me a graphic that shows that pinout and snag it and stick it into my schematic. There we go. You see there, pin 1 has the ground. The volts are coming in on pin 3. You got your transmit and receive on 4 and 5. So let's snag that. I'll do a little magic here. I'm going to cut out so you don't have to watch me snag it. And then I hit that icon over there. Boom. We're inserting the graphic, and I had already saved it off. I just edited it out. There we go. A little big. A lot of sap. Okay, we'll just right-click there, do an edit image, and then I can change the scale down. I'll knock it down to 30%. Ought to be reasonably easy to read. There we go. So for me, it just comes in handy to just go ahead and stick these graphics right onto the schematic that we're using. Okay, so now let's wire it up. We'll click the icon there to wire it up. And it looks like we'll go pin 1. And we're going to go take that over to what would be the ground. Because if you look there on the FTDI cable, pin 1 was actually the ground. Now we'll go onward. Pin 3 is the voltage. So that voltage is actually supplied from the USB port. Comes out at 5 volts. So you may have to buy a cable or a breakout board that is 3.3 volts. And according to the literature on the ESP, it requires you to connect 2 and 6 together for voltage for everything. About every example I've seen, those two are connected. Not sure why they just don't do that, at the where they get the boards made, but you always have to connect those two. And the lines, you notice, are overlapping. They're not actually touching. If they were actually connected, you would see the darker round circle like you see over there between pins 2 and 6. That means they're actually joined. So where you see them overlap here on the schematic, it's no big deal. Try to avoid it to make it a little easier to read, but I'm just kind of flying through this so we can get our project going. Definitely our project, there's a lot more to it than simply programming this, but we do need to make this programmer so we can pull it off. So next thing, we're going to need a couple switches because to program it, it has to be in a mode when it boots up where it knows that it's going to be in the flash mode to program. And the way they do that is they take GPIO 0 and take it to ground when it boots up. So if GPIO 0 is grounded on when it first turns on or powers on, it knows, hey, they're going to flash me, so it goes into a flash mode. So I'm going to go looking for a couple switches. I type in switch here, and lo and behold, it's not flagged as a preference. So I'm going to go up to preferences and component libraries and look down through. I don't see it there, so I'm going to click add, and then it is actually on the install in the default library for KiCAD. KiCAD's libraries, there is a switch library. It just wasn't added by default on mine here. So now I can go back and add a component. If I type in switch at the top, I'll get to all the pre-canned library components. So I don't have to draw them myself. You can draw them yourself. If you have something that isn't in the library, you can create your own. There we go. We got a single pole, single throw switch. Let's see what else we need. I have a special switch really that I like to use. Let's see if I can find it in here. There's a push button. We're going to have a push button. That'll be for the reset button of the ESP. But there we go. I'd like this switch because I want to either pull it down to ground or pull it high to the VCC. So I'll get this little 3-way switch. There we go. And we'll call that flash, because that's why I would switch it, is to flash it, to program it. And let's move that over to the right a little after. Well, first let me get this, and then I'll move it over to the right, rotate and move it. Okay, let's grab that sucker. I'll just fence around it, move it over. And fence it around again, hit R for rotate. And I kind of want to move it up, just keep the lines from going everywhere. I'll get this thing just right where I can try to minimize the number of elbows in the lines. Oop, I missed my mark there. I need to zoom in a little. When I zoom in, I'm just using the scroll bar. Of course, I'm just left clicking to start my wire. There we go. So that's GPIO 0 is going to the switch. And then now we'll make pins 1 and 3 of that switch go either to ground or to VCC. I'll take 3 over here. I already don't like the look of it because I don't like all those bends. I like to minimize bends. So I missed a mark there. And we're going to ground. Pin 1 again is ground. And something happened here. I'm not sure what happened, so I'm going to go over, and that junction icon over on the right there, I could clean that up, that connection up. make sure it definitely knows those two are connected. And now I'm going to try to clean up these elbows there on pin 3 to pin 6 of the ESP. To delete, let's see, to delete, it's best just to click, I believe. Let me look here. There we go. Just hit the pointer icon, click on the wire, then hit the delete key. That'll get rid of wires. That takes care of that one. I'm going to hit save before something bad happens. Got a little extra here from where I move things, so just click on it, hit the delete key on the keyboard. So there, now we have our flash switch, and I'm ready for my reset button now. Got to get that in there. Reset, you see, is that second pin down on the right on the ESP. Yeah, we just got to get that over there. So let's click on the component icon. I'm going to type switch. That'll narrow the results here. My keyboard's for some reason typing extra characters on me. And now I'm going to look for just a momentary switch, push button. Just press it in. When you release, the switch breaks. So just take it to ground and then let it immediately boot back up. So to reset it to flash, you would flip the switch to flash, and then you would hit this reset button we're putting in there. Gonna drop it here. And so we want to get pin 4. Try to get it straight down. Nice. And then we'll take this one on over. We'll just hit that ground plane like that. I could have went straight down as well. Whatever you like to do. Happy little wires. Okay, so that's basically it for how to use KiCAD to draw a schematic. You saw how I went and got my components and different things. So the next stage of the workflow, let me go ahead and mark up some things I want to put the name on there and everything. That way if I share it with anyone, they know what in the world what it's about. And like I said, this is actually the chip we're making is to program ESPs. So we'll make this chip and we'll use it all the time, or not chip, but printed circuit board. We'll use it all the time to program ESPs. It'll speed up programming them, because right now it's a big pain to wire things up individually every time we go to program it. And I just fenced a little, which allowed it then to grab so I could move it and center it. Okay, now I'm going to fence everything in, and we'll center everything. And get that text in there and blow that up a little bit. And I don't need it on the other, so let's fence it all off and move it out to the center of the page so it'll print nicely. There we go. And we'll save. So let's look at the next part of the workflow is to annotate schematic components, and it will automatically do this. Basically, it's labeling all the wires, just giving it a random unique identifiers for all the little networks where we join things. Like we joined a bunch of things to VCC, we joined a bunch of things to ground, and so it auto-named them for us there. Now the next part is we need to put footprints associated with all our components that we had, all those header pins that we laid down in switches. And what footprints do are they basically are showing the CNC machines where to drill holes and put all your pads for soldering to and all that kind of good stuff. So right now I'm going after some footprints right off of the web there in the GitHub repository. That's where all the folks that are contributing to KiCAD put their footprints that they have created and drawn. So gonna just follow this wizard, and I need some buttons, and I'm doing through hole. So I need the THT version of buttons, and I'm also doing pin headers. So I'm gonna look around for pin headers in here. You see all the different kind of components that people have already drawn out the layout for a CNC machine. That took care of the pin headers, yeah, button switches, and THT for through hole. There we go. It said it got them, and it says, hey, do you want to put these where you can get to them with other projects you're doing? The answer is definitely yes. Takes forever. I actually edited right now because it took forever for that thing to download. By forever, I mean like over 5 minutes, which feels like an eternity. So now let's look. We're gonna take these pre-canned footprints that have been drawn for us and then tie it to our schematic. So let me adjust some things here. I'm going to try to make it where I can show you the footprint on the left and then show you what I'm tying things to on the right. So now when I click down through here on the left, you'll start seeing all the different designs there. You can see where holes would be drilled through. It also shows spacing, the overall spacing of that particular component. So a lot of good stuff already in here drawn up. I've had to draw up a couple of things in the past that were a little goofy, non-mainstream, but for the most part, you can find it already made for you. So we got the 2.54 millimeter pitch, what we're looking for here. And so trying to tie that 2x4 header. There we go. That is it. So I just double click on that one. Looks good. That's definitely what I want. Select and double click. And there we go. Now they're associated there. You see that very top one, ESP8266, is now associated with the CAD file there or footprint that we just selected. So now I need to do one for the 1x6 header for the FTDI cable. There we go. Looks real good. That's exactly how I want it because I want to be able to stab those pins right into that FTDI cable. Double click. It's there. Now we're going after our buttons. This is a push button, so we'll just look for something. And as I actually edited out that I ran upstairs to measure the push button I had to see what it actually is. It's 6 millimeter. There we go. Now the flash switch, I had a special little switch, very tiny. I really liked it. You almost need a little tiny screwdriver to slide the switch so you can't inadvertently bump the switch and kind of embed it into a case, and then you'd have to use something small to move it. And that's what I wanted. So I actually drew that one up myself. So what I'm doing, I'm adding the footprint using that append with wizard button, but this one I drew up and saved on my hard drive, so I'm just going after it. Go. And so there it popped in. Click on Sean, which happens to be the real name of Walnut. There you go. That's the one I drew up. It just has the perfect dimensions for the switch I own, which was a little bit unique. And so we're done with that phase there. Now we've associated all those. Really didn't need to do that. The only reason I'm doing this is to show you how you can make a PCB. For what we're doing, we're gonna make our own from a perf board. What I'm showing you now, all this stuff, is if you wanted to send this off to a fab shop to actually have it made and sent to you in the mail in a couple of weeks, then you'd have a very professional, just as good as any component PCB sent back to you. So now the next part of the workflow is to go over and build that PCB layout. So the first thing you do when you go into that mode is you say read the net list, which is the network of wires, and then it brings over all your components. And you see how that's the little lines in between are all the connections of your various components. And what we're doing now is laying it out for the CNC machine to drill and mark and annotate all the stuff on your board. So I'm just trying to make a little room here. Get this stuff spread out where the chip could actually fit with these components around it, and your finger could still press the buttons or you could still flip that switch. So So then, the rest of it is drawing your connections, routing the board actually. So there's an icon over there for wiring the board. But the last thing I want to show you is how cool KiCAD is for showing you 3D, your part in 3D. And so right now, of course, we don't have any of the wires on there. It's showing you what it would look like in 3D. Now you notice that we're off on our the placement of the 3D object. So you just go in, double click on it, click 3D settings. I'm going to put rotate 90 degrees here. And let's take a look again. I hit Alt 3, that rotated it around, and let's see if I got any closer. So, okay, we're rotated around, but we're not in the holes. So we'll jump in and put some offsets to get those components to land right on those holes. Double click again, and see, I need it in shape offset. Let's type that in here. I'm going to go -0.5 inch back. You just got to fiddle around with this until you finally get it nailed. See how it jumped over? It went over 0.5 inch. And so let me work this real quick to see if I can get this dialed in for you. And I'll click on it, and when it goes hot, there we are, almost there. Almost got it over the holes. Again, this feature is awesome because it lets you know if things are going to hit. The worst thing to do is you look at your board and you're taking measurements and you're just hoping everything goes together right by being careful on every measurement. But it just means so much to be able to just land your 3D shapes on the board, see them to the correct dimensions. I could even add the ESP, or at least an obstruction type geometry that has the outer bounds of the ESP to make sure everything is going to land exactly where I want it to. And so if you were to mail this off, basically you just send your saved files off to a site like oshpark.com, and they take it and they'll print it out, but or they'll CAD it out and send it to you on a CNC machine. You want to make it as small as possible, though, because they basically charge you by the square inch. So if you can get everything nice, tight, and neat, it'll save you some money. And they always send you 3 boards. That way, if you damage one on the install, you always got more. And it's amazing how cheap they are. Something like this you could do easily for under $10. Back in the day of Steve Jobs and them, it was much, much harder in the 70s when they made the Apple I, because they had to wait weeks and weeks. And if they had a mistake, it was very costly. And that's why, they were successful, because they were kids of electrical engineers working in Silicon Valley before it was even called Silicon Valley. So they had a little bit of an advantage over the average hobbyist. I'm messing with this offset just a little bit more. Get it right where we want it. There we go. So that's KiCAD. Again, the reason we did this long, very nerdy video that isn't funny at all is based on user feedback, user comments. I know this video isn't for everyone, so hopefully you didn't watch it all if you're not into this part of it. If you're more into, raising awesome kids and parenting. But definitely this is a good tool in your toolkit. Everything you saw here is free. You can download it, and it's only up to your imagination what you do with printed circuit boards. And keep following along, though. If you haven't, subscribe, and you'll get to see the rest of the project. It is going to have a funny video, or at least our normal cringe-worthy bad acting intro, and showing you how all this comes together for the Element 14. So that's all I have for now. Please like and subscribe, and hope to see you next time.